function f is defined by the power series f of x equals 1 plus x plus 1 to the first power plus x plus 1 to the second power plus, I see a pattern. I think they're multiplying by x plus 1 each time, and they're multiplying by the same thing every term. That's called a geometric series. And I like geometric series because I'm already looking ahead to part A when they say find the interval of convergence. Geometric series, I don't have to test the endpoints. So I like finding the interval of convergence better than other series. Find the interval of convergence. Well, if it's geometric series, all I have to do is look at the ratio, right? I need to make sure that the ratio absolute value is less than 1. Each time I'm multiplying by x plus 1, I need to make sure that ratio is less than 1. X plus 1 better be between 1 and negative 1. So x better be between negative 2 and 0. So it looks like my interval of convergence is negative 2 to 0. Normally, when I'm doing Taylor series, Maclaurin series, and I need to find interval of convergence, I don't write it that quickly because I have to test the endpoints. But this was geometric series. The endpoints are never included. So that's nice. B, the power series above, is the Taylor series for f about x equals negative 1. Let's see. Yeah, that looks like a Taylor series about x equals negative 1, right? It looks like it's centered at negative 1. It's a bunch of x plus 1s, which is x minus negative 1. And they want to know the sum of the series for f. In other words, they're looking at this, and they're saying, you're adding up infinity things, what does it come out to? What does the sum actually become? What does it converge to? And we could do that, because we know geometric series. We know what they come out to. We know that the sum, when we add up all of those things, is going to be the first term over 1 minus the ratio. The ratio is x plus 1. This is just a geometric series. Geometric series, when you add up infinity things, comes out to the first term divided by the ratio. So I do 1 over 1 minus x minus 1. It looks like just 1 over negative x. So maybe I'll call it negative 1 over x. Is that all? Find the sum of the series for f. I think that's all. That was the next part B. I'm liking this question. Part C. Let g be the function defined by the integral from negative 1 to x of f of t dt. Find the value of g of negative 1/2 if it exists, or explain why g of negative 1/2 cannot be determined. So, before I even think about doing the integral, just this second half of it, find if it exists or explains why it might not be able to be determined. That sounds like a question about interval convergence. Right, I'm going to do this problem. I'm going to end up integrating f and plugging in an x, plugging in a negative 1. If x and negative 1, maybe there's a reason I can't plug them in to the integral of f, then it's not going to exist. Now I'm going to do it by integrating this version of x, not this version of x. But I do know I will be able to plug in those numbers. Make this really small, make it so we can see everything. I know I'm going to be able to plug in negative 1 and negative 1/2 because I know f of t, f of x, has an interval convergence of negative 2 to 0. When I integrate it, it's still going to have an interval convergence of negative 2 to 0. Maybe the endpoints will end up included then once I integrate it. That integrating and differentiating keeps the same interval convergence, but the endpoints might change. So I still know the interval convergence of the integral is going to be between negative 2 and 0. And when I plug in a negative 1, well, that's fine. It'll still converge because it converges between negative 2 and 0. And when I plug in a negative 1/2 for x, it'll still converge because that's between negative 2 and 0. All of that's irrelevant because I could just take the integral and try plugging in a negative 1/2 and see if it comes out to a number. But just I want to give you a sense of another way to look at it. But a pointless way because you can do this problem already without even knowing what I just said. I'm going to do g of x is the integral from negative 1 to x of f of t dt. Good job rewriting the problem, Mr. Novik. Maybe we can do something a little bit more this time. G of negative 1/2 is going to be the integral from negative 1 to negative 1/2 of f of t dt. F of t is just negative 1 over t. negative 1 over t dt. Integral of that, and that's just negative ln of t, absolute value of t, evaluated between negative 1 and negative 1/2. So that's going to come out to plug in negative 1/2 minus plug in negative 1. If I plug in negative 1/2, I get negative ln of absolute value of that, I'll just call it 1/2, minus, I plug in a negative 1, not that it's going to make a difference, negative 1 versus 1, because it's absolute value. I get negative ln of absolute value of negative 1, just call that a 1. This is going to be negative ln 1/2, that I could write as 2 to the negative 1, just to take advantage of some log properties to write it a little nicer, minus ln of 1 is 0, so minus 0. I could take advantage of log properties and bring this negative 1 down and make it negative 1 ln of 2, which would be positive ln of 2. That's going to be my answer to part C, ln of 2. And part D, this has not been a hard problem so far. I mean, that's a scary problem. I shouldn't say it's not hard, because I could imagine a person looking at this and saying that's hard. It's scary is what it more is. D, let h be the function defined by that. Find the first 3 non-zero terms in the general term of the Taylor series for h about x equals 0. And find the value of h of 1/2. Okay, h of x is f of, I don't know where this problem's going. I'm just going to kind of do the things that make sense to me and jump out at me right away. It's going to be f of x squared minus 1, which means I'm going to plug x squared minus 1 into f of x, into that thing. Now from here, it's right here. You're doing f of x squared minus 1. That's going to be negative 1 over x squared minus 1. I'm just replacing the x here with a x squared minus 1. So, just rewriting that down here. I get that h of x is negative 1 over x squared minus 1. Now they ask 2 things about that. They say find the first 3 non-zero terms in the general term of the Taylor series. And they also want to know the value of h of 1/2. So first I'll find the first 3 non-zero terms. Now I can find Taylor series in one of 2 ways. Either I use that formula where I do 0th derivative evaluated at the center, x minus the center to the 0th power over 0 factorial, plus first derivative, first power over 1 factorial, plus second derivative, second power, 2 factorial, plus. Or I take advantage of series I already know and shape them to match what I'm trying to figure out. That's what I'm going to do in this case. This is a geometric series in disguise. This is one of these ones where I'm going to take it and I'm going to transform it. First, maybe I'm going to write it in the other order. And then I say, well, my geometric series, I try to make it in like this form. So I need a 1, not a negative 1 at the start of the denominator. So I'll multiply everything by negative 1. I'm going to pull out a negative 1. I'm going to make this positive and make it like that. Hopefully I didn't lose you there. I just kind of distributed negative or pulled out a negative or whatever you want to call it. So now it looks to me like it's in this form. I have a1, 1, 1 minus, 1 minus, r x squared. So that's what a geometric series comes out to. Something came out to this. The series must have originally looked like the sum of a bunch of things from 0 to infinity of the first term, in this case, first term 1, times the ratio to the nth power, which is going to look like one plus x squared plus x to the 4. I start off at 1, and I have a geometric series multiplying by x squared each time. And they ask for the first 3 terms, I believe. First 3 non-zero terms. That's the first 3 terms. And the general term is x to the 2n. That takes care of half the problem, where I find the first 3 non-zero terms in the general term. Now I need to find the value of h of 1/2. That's not even calculus, is it? Unless I'm missing something, which I often do, h of 1/2 is going to be negative 1 over, I'm just plugging into this guy, negative 1 over 1/2 squared minus 1. So h of 1/2 is negative 1 over 4th minus 1, negative 1 over negative 3/4. I got 4/3. What did you get? Oh, you got 4/3 too? Oh, that's fantastic! We're all on the same page. Oh, that's good to know. Let's go get ice cream and celebrate.